yes, and my colleague Stelios, okay, we're going to present you our work about how can we use some techniques to support the automated process discovery. Okay, when processes have some elements of big data inside of them. Now, first, it's a very short introduction about what is automated process discovery. I'm very grateful to Catherine that during the morning made a presentation that I hope made more clear what is automated process discovery. Now, we begin with an event log. Okay, we have event log. An event log is nothing more than data that have three necessary elements. Okay, the first is case ID, the second who, meaning the client, the customer. Okay, who. What is the event ID or the activity? Okay, what happens and when it happens, the timestamp. Okay, assuming we have a data set with at the minimum with these three elements, we can feed some process mining algorithms and generate a process map like this. Okay, this is automated. You feed with data, you get the process map. Okay, very useful. Now, I think already Catherine has demonstrated that one problem with this is that in flexible environments, when you don't have a production line, when you have, for instance, healthcare or customer service, okay, you generate spaghetti diagrams. Okay, and spaghetti are useless. Okay, you cannot interpret them. Now, assume that you find a way to resolve the spaghettiness of diagrams. Okay, assume. There are still some processes that are inherently complex because there is a large number of activities, a large number of steps involved. For instance, look at this process. Okay, this is not spaghetti, but you have a lot of activities, a lot of steps. This is a very complex graph. Despite it's not connected, it's not fully connected. Okay, it's very sparse, but you have a lot of steps. Now, this is not good. Imagine you are a manager and you tell your clients, oh, we have a process for claim handling. This is the process. I think you cannot earn any credits, neither from your clients, nor from your employees, nor from your stakeholders in general, okay? Or put yourselves in this position. You are buying an equipment, a machine, and you want to learn how to handle this, and someone tells you, oh, there is a process, read the manual. Okay, but you cannot understand this. So, ideally, what we like, the process is this, it's very complex because there are a lot of steps. Okay, but how can we facilitate the process of understanding? Now, ideally, we would like to hide all this chaos, okay, and just focus on some small phase of the process. Now I can interpret this, I have a feeling what happens. And after I have understood this small part of the process, maybe I can see where it is located with respect to the whole process, and then focus on another small part. Okay? I mean, the human brain, there has been research on this, can anticipate a process that has at most 30 elements. Okay? If there are more than 30 elements in a process map, then our brain gets confused. Okay? Even if you are an expert in process management. Imagine that most people are not. So this is the intuition of our work. Okay? We want to divide, we want to partition the graph into small and coherent elements. Now, some related works, they're related, they're not trying to resolve the same issue, however. Okay? The fuzzy mining and the fuzzy clustering, you have a map like this. One approach is to collapse a set of processes and put them in a more small map, in a smaller map. However, okay, you can have this map, but you cannot see what happens here. Okay, this is hidden. Okay, and also, if your process is really big, there is also the computational issue. Okay, you cannot decompose this discovery into multiple machines. So there is an issue. Another issue is an approach proposed by Van der Rast, the passages, or the single enter, single exit nodes by Dragana. The problem with this is that they divide the whole graph in very small fragments. Too many and very small. Okay? So, what is the basic steps, the basic idea of our approach? Now, first, follow a clustering, a graph partitioning. This is the idea, okay? Now, of course, when you cluster, you want your clusters to be coherent. Now, based on this clustering of nodes, okay, go back to data and partition the data, decompose the data set into subsets of the activities. Okay, you remember the initial format of the data set. You have 3 columns, okay? Case ID, event ID, and timestamp. Now, you say, this is not one process for me. Event ID from 1 to 100, one process. From 100 to 200, another process. So you partition the data set. You decompose the data set. Then, on every subset of this data set, you discover a process map, and then you aggregate them to get the whole picture. Now, to this end, we define a very simple yet very effective metric, the connectivity metric. Very simple definition. Imagine that you have 2 activities, activity I and activity J. Now, if there is in the data, in the event log, some direct succession, okay, I mean in time, for some particular case, okay, count it. And divide this by the total cases, by the total number of traces. Now, this is the connectivity metric, and I use Cij for this. Now, when I will do the graph partitioning, I want to consider 2 criteria that will help me to get effective decomposition. Now, the one is informativeness. I want rich information in my clusters. I don't want small clusters that contain no information. And what means rich information? Rich information means that when some activities have strong dependencies, they should be in the same cluster. This is rich information. Why I want this to maximize? And what means maximum informativeness? That frequent patterns should happen in one group. A frequent pattern should not be cut off. Okay? It should be isolated in one group. Now, all frequent patterns should be located in one subgroup. And, of course, the extra behavior, okay, that may happen should be outside this group. Okay? So, by maximizing this formula, we have a feeling, okay, that this will happen. Now, the other criterion is robustness. What is robustness? Robustness has to do with overfitting. I mean, I don't want my clusters to contain irrelevant activities. Okay? I want the activities that will be clustered together to have indeed strong connections. Okay? So, how I reach the situation? Stability or robustness takes the form of clusters dissimilarity with other clusters. So I want my clusters to be well separated. This is the formula. And I want to minimize this. Okay? For every cluster. For every cluster. Now, if I sum the informativeness of all clusters, I get this. If I sum the informativeness of all clusters, I get this. Now, not surprisingly, if I sum up I, informativeness and robustness, the global, the overall metrics, equals the number of clusters. This is very important. Why? Because the number of clusters is a constant number. That means that while I maximize informativeness, I simultaneously minimize robustness. I can address both criteria simultaneously at the same time. And this is very, very, very important. So, I can just focus on optimizing one metric. It is the same. By optimizing the one, the other one will get automatically optimized. Okay? Now, so for the next slide, let's assume that I'm minimizing robustness. This is robustness and this is the formula. Okay? I just want some basic notations. I'm using the capital bold letter C to denote the symmetric matrix, okay? I mean, imagine I have Cij, the connectivity metric. This is symmetric. So if I put all the rows and all the columns, the activities, okay, I have a symmetric matrix. D is the diagonal of this matrix, okay? And E subscript M is a vector element, a vector that has one, if one activity is assigned to some particular cluster, and zero otherwise. Now, after some algebra, I don't want to focus on the maths. There is analytically explained in the paper. Okay. Now, after some algebra, we can calculate that the optimal vectors E hat n. Do you remember the previous equation that have the connectivity metric? Now I have matrix format. Okay. Now this is the formula. I want to minimize this, and this is quite easy to minimize. Okay. After some more algebra, okay, I find that the minimum value comes from this equation. Okay, and the optimal allocation comes just for this multiplication. Okay. I don't want to confuse you with more math details, but the ultimate conclusion here is that I get the optimal assignment with just the multiplication. Okay? Of course, E, I need to find the eigenvectors, and then I need to find the eigenvectors that correspond to the largest eigenvalues, etc., but you don't need to know this. Just make this multiplication. Okay. Now, this is the whole process. I'm taking the event log, I'm decomposing using the formulas that I just showed you. So I have many logs, small and manageable. From every log I discover a submodel, okay, small pictures that I can understand, I can interpret, and then I find some method to aggregate them. Okay, now, I don't have time, but I have to say that this is not an automated procedure. Okay, I have some comments in the discussion. Now, first, why do we need to do all this? Now, these are some benchmark data sets. Not very large data sets, okay? Not very large. But if I use a conventional algorithm, the ILP algorithm, it's an algorithm to automatically discover processes. Now you see that for all of these data sets, I fail. I cannot. Okay? Why happens this? Because this algorithm is exponential to the number of activities. And most process mining algorithms are exponential to the number of activities. So they fail. Even with a very strong computer, they fail to discover. So this is why I need to decompose. I think this is one argument. Now these are some results with different methods. Okay, this is our method. We want the red box to be maximized, and the red box is informativeness, and the green, or I don't know what color is this, box to be minimized. Okay, this is the largest cluster because I don't want to produce large clusters. Okay, it's not a solution from 100 activities to deliver one cluster with 90 activities and 4 other clusters with 2 or 3 activities. Okay. Now, I want to keep my largest cluster at minimum. You see that we have compelling performance. These are the other algorithms. We are the winners both in informativeness and in the largest clusters. Okay? Now, and also with robustness, some other testings, we have very good performance for all the data sets. Now, we also make some tests with the parameters. For instance, why do we consider just the direct connection of 2 activities? Maybe if it happens after 2 or 3 steps, it's also related. Yes, but it's not good for the decomposition. Because when you cut something, okay, it's an immediate cut. So you see that the performance when you consider just immediate connection outperforms the other variations when you put some fading distance in the connectivity method. Now, the last slide. approximately, our method is capable to partition in an horizontal way the event log, while simultaneously optimizing two criteria. Okay? Informativeness and robustness. Now, when should you use it? Of course, it's not suitable for every situation, okay? We recommend to use it when you have process with large numbers of activities. Okay, there are many processes that have these characteristics. We really do not care what is the discovery algorithm that you will use. You may use the alpha algorithm for Petri nets, you will use the ILP algorithm, you may use fuzzy miner, you may use whatever you like. Our method is agnostic to the discovery algorithm, but it's not fully automated. It is designed for decision support. You have submodels, and we just provide some recommendations how to merge these submodels into an overall model. Okay, this is a draw. We cannot fully automate the process, but I think that the advantages are also important. Thank you.
I have a question.
Please, I'm not surprised.
I'm sorry about that. The question is actually a curiosity. If you work within contexts, right? And I'm not sure if this will be one-to-one adaptable. Let's say, you say, I get a pattern that frequently occurs and I put them all in one cluster, right?
Mm-hmm.
But sometimes this pattern occurs frequently and because all the other activities also need it. And you are clustering it together in one group.
Yes.
And then you lose context. Did you think about that?
The context here, I may return here. Now, you see that it's faded. You don't lose it, but you cannot afford to...
You aggregate it back,
Yeah,
I know.
yeah,
But
yeah.
you might misinterpret it in this intermediate analysis.
Yes, you're right. You are right. But what to do if I'm in this situation? Okay, I mean, my alternatives is either this, I can do nothing, or I have to lose some context.
Yeah, but this is the question. Why did you come up with this idea of aggregating the patterns, the frequent ones? Was it because of a context, or was it because you just think, okay, this is one of the requirements of clustering?
No, we made a lot of experiments, and this produces good results in terms of optimizing the two criteria. Okay, so we also tried different patterns. For instance, let's put a time filter, let's put a resource filter, let's put other filter to put horizontal boundaries. There are 7 popular ways in the literature to put horizontal boundaries. Okay, we have tested them. This produces good results with respect to this criteria, of course. Okay.
Okay, I'm satisfied with that.
I also have a
Thank
question.
you. I'm satisfied that you are satisfied.
That's a good question.
I wanted to ask you, like in terms of like time, can you do this kind of adaptatively? You know that you do during time.
Oh, very good question. Very good question. If I have put it a future works slide, that will be in, because you can incrementally update the clustering and you can adapt with respect to time.
Because
Yes.
that many times it's changing, so it would be nice
Yes,
to have
there is
that.
concept drift.
Exactly.
Exactly, there is concept drift. But you can incrementally update the algorithm. You don't need to solve the eigen problem again. You don't need to, because this is computationally expensive, okay? You don't need to solve it. You can just incrementally update the eigen values. Okay? There are some very good mathematicians that provide us with very good tools about that. And you can incrementally update the clustering, yes. But of course, up to the limit, up to some limit, error accumulates and you have to start again. Yes, this is a very good direction for future work. Thank you.
And responsibility for content of data is for man, not for algorithm.
Ultimately, yes, there should be a human that will decide.
Yes.
Ultimately, this is for decision support.
Yes, yes.
It's not fully automated. It's just a tool when you can do nothing. So You just facilitate the human to produce something.
Thank you.
Okay, thank you.
Sorry.
Oh,
I hope to get a bit with but my question actually is related to what Martin asked. I think there is a question of defining the similarity harmonies. How much do you say if the two event classes, 9% are similar, then you put them into the same group, or you can define 0.5, you will accept it and put them into the same class. That is will influence how many participants you will get and then how much context you would be willing to sacrifice.
Yes. First of all, I prefer the term connectivity and not similarity because they are connected, but maybe they're not similar. They are just connected.
Yeah,
Okay, so I happen and then you happen. Okay, so there is precedence.
So it's a sequence of
The
the
sequence, yes.
activities.
Now, the truth is that this is an NP hard problem. Okay, so maybe this is an approximate solution. Okay, I cannot solve it analytically. Okay, this is still an approximate solution. Even with all this algebra, still my solution is an approximate solution. So maybe some faintly connected activities are grouped together. Maybe this happens, but it also depends with the number of clusters. Okay, the greater the number of clusters, then the more confident I am that I only cluster frequent patterns. But when I cannot decompose and have two activities. Okay, I need to keep some kind of context. So, okay, 5 clusters, 6 clusters, 7 clusters, okay. But then, so if I put a small number of clusters, then maybe I'm prone to what you mentioned.
Vamos?
Thank you.
Now we have 2 papers and 1 presenter. Presenter is Anna Bajc. And first paper is, I don't know, that will be an alternative approach to in-memory data processing or process mining in
Okay, I will follow the
Okay.
I'm not the first author in the previous paper, but here this is my field, and I'm first author and try to speak about the problems of converting the transaction data to event logs. We talk about here about process mining techniques, different techniques that we can implement, but how to collect the data in the specific format to implement these techniques. I will talk about this problem in this second presentation. Okay, first I will describe research problem and try to explain, but it will be briefly because we have already one presentation, a specific format of this event logs, and then try to describe logical structure of transaction data that are collecting through ERP systems. ERP systems are enterprise resource planning systems. Different approach exists for event log extraction, and we capture the limitations and also the key areas where they extend each other, and focusing on artifact-centric log extraction. I will explain later what that means. In paper we present a logical meta model and discussed about its use, how it can be used for further development of different tools. Organization adopts ERP systems to integrate all data and to integrate all business processes in one single database. ERP system handles a huge amount of data related to actual execution of business processes. But the problem is the reference process model are very complex, and also we can find the modeling mistakes, modeling errors. As for here, for example, there are modeling errors in 5.6% of the event process change in this SAP
widely used on the market. So there is also the reference, the modeling errors in this reference model. The goal is to discover from transaction log a model of how the business processes are actually carried out. But the problem is how to convert this transaction log to event log. That is the main problem, to see the gaps where we plan to use this system in one way, and we now want to see how employees are really using the system and how employees really carry out these operations. Okay, process mining very briefly. Set of data analysis techniques. The goal is to discover process model from event logs in this presentation. We don't do detailed analysis of gaps and or deviation in processes, but the problem is this specific format of event, which is the required input in process mining techniques. It assumes that assuming that events are recording sequentially, and that one event is only one event refers only to one activity and only to one process instance. That's a problem. An event log required by process discovery techniques has a process-oriented data structure, which differs from the data-oriented structure of relational database. Here is a general event log structure that we found in literature, and to illustrate how data-oriented databases looks like, I will describe main characteristics of Microsoft Dynamics Navision ERP systems. To our best knowledge, the log extraction approaches have not been yet applied to this ERP system. Because of that, we use it as an example of describing data-oriented databases. There are two types of tables, master tables and documents table. Master tables describe information about basic business entities in non-functional areas, such as vendor, customer, item. And document types is implemented as a pair of tables, where document header contains information about transaction information. And on the other side, document line table describes the properties of each involved item, of transaction. Document line table is subsidiary to document, and all documents are presented as a parent table used for transaction entries. We observed one more type of table in this ERP system. It's a document history table type. Contains a transaction history for documents that can be already posted. On the first figure, you can see sample data from the transactional type table. These tables are required to be implemented in the system to collect the information about events that we can then convert it automatically to event log. The second figure describes design of the timeline event table. Timeline event table refers to transaction type and has column transaction type and also source line ID and source document ID. So it refers to the document line table and document header table that we can collect transaction information on item level and also on the header level. So ERP systems are constructed in that way that data related to a particular business process is stored across multiple tables. So if we want to collect data for one business process, we need to connect more tables and pull the data out. And tables are connected through key relationships. Transaction log extraction approach observes the process as an isolate instance that don't have interaction with other processes or entire environment. The limitation of this approach is the lack of clear notion of a case of process instance. So which causes problems in data convergence and data divergence problem. These problems are related to relationship, many-to-many relationship that we have between two data objects in the databases. One of the solutions is to select the lower level identifiers, and maybe it's for some system a good solution, but for ERP system we can't select identifiers to be document line. It doesn't solve the problem of data conversion and data divergent problem because every document type is represented as a pair own execution and can be related to another artifact that we can see in this picture. This is just one example on artifact choreography of delivery process where an order is split into multiple deliveries and the states of delivery is presented on the diagram. So artifact-centered model allows model to express this one-to-many and many-to-one relationship between cases, which was problem with the traditional log extraction. So now we can express one-to-many and many-to-one relationships. Some documents in the ERP system, as I already said, that is very important, are represented by two pairs of tables, document line and document handler. Here is presented as a classes in ontological meta model. And each document now we have to look as to have its own execution. So one document can depend on collection of other documents, and the dependency between documents are stored on the item level. First step is to identify artifact scheme. Artifact scheme is recognized as a main class related to an artifact. It only contains a table from the database, from relational database, which are linked by one-to-one reference. That's very important to prevent the data divergent and convergent problem. So we collect multiple tables from relational database
noisy. And I think that when it will evolve, you have great potential. However, there is a pitfall, in your approach that you have to take care. Artifact-centric models are mostly known as a state transition model. Okay? When you talk about business processes, most people, okay, the first thing that comes to mind is a transition, control transition approach. So you have to take care because changing in state, okay, and making a transition is not very clearly defined in your approach. Okay, it's a different thing mining from straight state transition from for control transition. So you have to find a way to formally define why this is equivalent, or what is the equivalence between your approach and the control flow.
Thank you.
Thank you for your suggestion. Thank you.
Another question?
Just a question. Did I understand it right? You use the ontology not as a pre-processing support of the data, but for a post-processing explanation of the process to the user. Is it right? Yes.
Post-processing.
Yes.
For the user, because business analysts find these existing two very complex fields. So this model explained in the post-processing phase, but also it's very useful for pre-processing if we identify the database stream and then identify artifact stream. So data object that is useful for pre-processing, processing to the event logs, for converting them to event logs. So these artifacts and artifact
for surveys that we're currently working on, and some problems that we may run into and how we plan to solve them. One word of introduction about this presentation is that first I will give a very brief introduction about the current state of surveys and survey platforms, and then I will tell you about the approach we're planning to use about solving this problem that we're going to run to, and that's sort of it. Currently, surveys are conducted in a few ways. The first way is that you hire someone to go around with a notepad and ask video questions. He then, after getting the answers, goes to a post-processing phase where the data is tallied up, and then you can use this data to make decisions. The other, albeit now archaic way, is to send out emails. Basically HTML formatted emails with forms which you can submit, and then the data goes somewhere which you can also analyze. And currently, the newest approach is actually platforms. There are many web platforms now that are actually also mobile platforms which serve for everything from filling out, defining, and analysis at the same time. Our solution falls into the third category. So, the currently existing survey platforms have very interesting interfaces. They're very, very friendly, very easy to use. You don't need to have any predefined knowledge about conducting surveys, and they will guide you through it without much issue. And you have a way to choose the group or subgroup of participants that you want to participate in your surveys. For example, people of age of 18 to 24 that have completed at least second degree of education and have had one child and are not married. And you can target your surveys like that. But that is also a problem, because there are people who simply do not have the knowledge of statistical distributions or targeting for that matter. They simply need something to, they simply need to know something. They don't need to know who is answering or what. They just need a group of people to answer a question. And this is where we run into a problem that we cannot obtain a broad public. We have to target our servants, and we sometimes don't want to do that. And our solution allows registered users to create surveys, and anyone can view surveys, but only registered users can only registered users can participate in a survey. This is to reduce data toxicity, as people would have to actually register to participate. And what difference in our solution is that we have a one-step registration process, and that we do not have the need to target any distributions of users. We simply allow your survey to be hosted, and anyone can view it, and anyone can fill it out. The potential use of this platform, other than being hosted online as a public service, is that it can actually at the same time be hosted in your internal enterprise cloud or information system, as in that you can host the same application in your internal organization as an internal service, and you can ask questions. And this is invaluable as a decision support system in multinational organizations for anything regarding their employees. And other than that, it would secure your data, as the data is physically located in your organization. It's not somewhere else in the cloud or located anywhere else. It's literally in your organization. So we argue that this platform can easily be used as a decision support system as well when used within an organization. However, it is also very important that we allow anyone to launch a survey and have other people complete it. So you do not have to have experts in the field of psychology or social studies to conduct your surveys. You simply need an answer to some questions, you design a survey, and you let people fill it out and see what you can do from that. And why do we need MapReduce for this? It's relatively simple. As we get more survey data, our data will rise. So we have decided to be pessimistic for each answer to a survey, you have our own database. And we have made an assumption that in the worst case scenario, if you have questions with 7 answers and people answer them, by the time you get to about 1 million completed surveys, you're going to have at the very least 50 million rows in the database containing bar chart data, int data, or something like that. But this is not the main reason why we're being pushed into the big data spectrum. What is really capable of pushing us into the big data is demographics data. Every user who fills out a survey is free to give us some data about themselves. How old are they? How much do they like cake? What's their shoe size? They're free to give us this data, but they do not have to. So this provides us with many optional data, which relational databases struggle with. So in this situation, we would benefit much more from using a MapReduce approach. And storing this data in a relational system is, well, capable of being stored in 2 places, either with the answers in a table or in a different table. But no matter where we store it, because it's not structured by default, we are going to be left with many null fields. And additional non-structured potential features is open-ended answers. You cannot anticipate everything someone is going to give you. So you cannot anticipate every answer that you can get. So you leave it open-ended. They can write anything they want. And this is by default a string that can mean something. And you need to use some sophisticated algorithms to analyze this data, which is a good place for MapReduce. Also, there is multimedia data. What if you want someone to gauge a picture or tell you what sort of place they like to visit? You can use pictures, you can use videos. And this is also a potential spot for MapReduce algorithms. Another potential feature is that you can link to other sites. And internet websites are by default non-structured. So in order to analyze this, you would need MapReduce and a non-structured database. So currently, our data is stored in a relational database, which gives us all these issues. And while caching is available, but we can have exponential growth of rows, as already mentioned. And as data grows, and as requests grow from the user that want to analyze their data, we need to distribute. We simply need to distribute. One database server is not enough. So this is what it currently looks like. We have a table for surveys. Every survey has questions, and every question has answers. And currently, survey data points to an answer within a survey. Each answer is a row in this table. And this will inevitably lead to issues. Our proposed solution is to have additional database management system, such as CouchDB, which by default supports MapReduce and will allow us to have demographic data stored within every answer, which we can analyze as time goes on. So, NoSQL document storage is much more suited to this data that we currently have, because it is not structured. Demographics, first, we're not forcing anyone to give us their demographic or anything about themselves. So we have non-structured data, along with multimedia data, websites, and so on and so forth. So NoSQL is a good choice for us, and CouchDB is good because it supports clusterization by default, and it supports MapReduce by default. So we believe that utilizing CouchDB as a NoSQL database can help us solve these potential performance issues, and we believe that demographics data is, in fact, more suited to a document-based database. And we're very eager to see how this will affect our performance. Because who knows, maybe this interaction between these 2 databases will actually end up being worse. We do not know. And that's it. I really hope that I brought something new to the table. And if you have any questions, I am open to any of them.
So I have a question. Do you try to do
actually thought about that, but we cannot test for that. We're currently working on trying to move away from the relational database a bit.
Yeah, okay, so my suggestion then for you would be try with Hadoop. First,
Okay.
because you can do it parallelly, and secondly, because I think it could give you much more options than this one.
Alright, thanks. Anyone else?
Also,
Yes.
another suggestion. Have a look at Apache Spark. Have you seen this? It's showing some very promising uses and going against some of the limitations that you have with MapReduce type of algorithms. Have a look. It
Okay.
might be. I don't know if it's applicable to the.
I'll definitely look.
Yeah, to what you have, but have a look at it. Okay.
I'm happy you mentioned that because every work that is being published with MapReduce these days, the basic question that comes after the presentation is, did you compare it with Spark or did you consider Spark? And if for this work you have introduced what you are doing, and it's very decent work. I'm happy with your presentation. I just want to confirm, are you a PhD student here?
No, I'm not yet.
Okay, not yet. And I would suggest you to exploit the parallel options you have for attacking the same problem. And even if you don't go on and use it and implement it, but that you justify in a further paper, why not? Because this would complement your research.
Definitely. And I would be more than glad to see what actually will solve this issue, because one relational database will not work with these many non-fields. So yeah. All right. Thanks.
Thank you.
Thank you.
Thank you for attending this section. Now we continue with we have in the same